Hi class, we are in section 6.3 on translational equilibrium and we're doing question 35. 35 is a classic problem of tied things together. You've got masses tied together and you've got different forces based upon where is the mass. So for instance, in the lower string, you've got a tension based upon the mass of the bottom guy. But in the top string, you have a tension based upon the mass of both of the weights below it. All right, so that's what they're asking. They're misspelled find. I wrote it fed. Find the tensions in the string connecting the two blocks, that's A, and then the string that's tied to the wall, B. And you have a 31-degree incline. All right, so since we know that this one is going to be mg, okay, and then we've got the normal force here. Normal force would be acting down, or it's the weight perpendicular, the perpendicular part of that one, of that mg, and then the parallel force mg would be mg times the sine of 31 degrees, and this is mg times the cosine of 31 degrees, but it is going to cancel because I have a normal force coming out of the board. The board is pushing onto the force the same as mg cosine of 31, so these cancel. So I've got a force moving down the board that's wanting to pull on this string. This amount is pulling here. Okay, that mg sine of 31 is pulling down, and the tension is pulling up equal. And I know it's equal because it's not moving. If it's not moving, that's in equilibrium. It's in static equilibrium. And so we'll see that we'll do A first, that mg times the sine of 31 degrees, okay, equals the tension, okay, equals the tension in A. Well, we've got 1 kilogram times 9.81 times the sine of 31 degrees, okay, equals 5 point, I don't know how many significant digits. We've got 2, so I need 2, so I need 5.1 newtons. So this is A, 5.1 newtons. And the only thing difference in here is that my tension is not based upon the mass of the first block, but the mass of these both blocks. And I assume that the rope in between weighs nothing. That's a typical physics-y kind of thing. Life is weird in physics land, but that's just the way it is. So B is going to equal mg times the sine of 31, only my m is bigger. Okay, equals t. So this is going to be 2 plus 1. So I have 3 times 9.81 times the sine of 31. 2 significant digits is 15.2, so that would be 15 newtons. Okay, not as bad as it seems. Anytime there's a picture, it's scary, but the math here is nothing. Okay.